Find two unit vectors that are perpendicular to both 1, -2, -2, and 3, 0, -1. So this actually has to do with the fact that if you have two vectors, u and v, and this is a three-dimensional picture, so let's say u is slightly towards you and v is pointing away from you, and then there's the cross product u cross v is a direction that's perpendicular to both of the vectors. Okay, the definition of a cross product is its direction is given by the perpendicular direction from both vectors, given by this thing called right-hand rule, and the magnitude of this vector is the same as the area of the parallelogram built by u and v. That's the definition of a cross product. So cross product is nice for this question because it immediately gives you a perpendicular vector, but it's slightly different because it's asking for unit vectors that are perpendicular. So after you find out what vector this is, then you should normalize this so that unit vector means it's size 1 vector, right? So you have to divide the vector by its size so that it becomes size 1. And if you have one vector that's normalized, then you just take the negative of that vector. It gives you another unit vector in the other direction, right? So if you have two vectors, then there are two directions where it's perpendicular to the plane built by u and v, right? So that's one, and this is the other one. Okay, so that just tells us that we should calculate the cross product. You calculate the cross product by using this determinant, ijk, and then you place the two vectors. Which is I, and then delete the column and the row, you get -2, -2, 0, -1, minus j, and then you have 1, -2, 3, -1, and plus k, which is 1, -2, 3, 0. And that's 2 minus 0, so it's 2. 1 times -1 is -1. Minus -6, so it's plus 6, so it's 5. And there's a minus in front, so it's minus j, minus 5j. 1 times 0 is 0, minus -6, so it's positive 6k. And so this is the vector that's perpendicular to both 1, -2, -2, and 3, 0, -1. Now, if you wanted to check whether indeed these vectors are perpendicular, you can just do a dot product to see that they do give you 0. See, if two vectors are perpendicular, their dot product gives you 0, right? So if you do 2, -5, 6, and you computed dot product with 1, -2, -2, 2 times 1 is 2, -5 times -2 is plus 10, 6 times -2 is -12, and indeed this is 0. So you know that these two vectors are perpendicular. And you can also check it by doing this dot product with 3, 0, -1. Okay. Then what you need to do is one vector, let's call this vector w hat. When you have a unit vector, you use this symbol hat, okay? So w hat would be the normalization of this vector, which means you just divide the vector by its size. But what is the size, or what's the magnitude of this vector? That's square root of 2 squared plus -5 squared plus 6 squared, and that's 2, negative 5, 6 over square root of 2 squared is 4, negative 5 squared is 25, and 6 squared is 36, and I get that this is square root of 65. So because this is square root of 65 and you're dividing, all of these components should be divided by. So that's one answer. So that this is one answer, and the opposite one would be just negative of this, right? Because it has to be on the same line to be perpendicular to both u and v. But if it's directly negative, the size of this negative w hat would still be 1, right? So the other answer would be negative 2 over square root of 65, positive 5 over square root of 65, and negative 6 square root of 65. And that's it. That's the answer.